So the first thing that we're going to do today is I'm going to give you a note card. And those of you who weren't here yesterday, you don't have to worry about doing this activity. But those of you who weren't here yesterday, you're going to receive a note card, and you're going to write your name on one side of the note card, and on the other side of the note card, you're going to open up your notebook, and you're going to have 2 minutes to write down the answer that you have for number 3 and number 4. So you're just writing down the answers for number 3 and number 4 from your notebooks. If you don't have the answer for number 3 and number 4 in your notebook, just write "not done" on the note card and then put them in the box, the hand-in box. Any questions?
Not the questions, just the answers.
Just the answers. No questions, just answers. Okay, so you're going to turn your note cards into the box right now, and then I need for you all to pay attention. So we just finished up our states of matter unit. So what are the states of matter? Solid, liquid, and gas, right? So and how do you go between them? By adding or taking away heat. Now that was a pretty easy chemistry unit for us, but now we're going to be moving forward into some of the more hardcore chemistry. Now I intentionally put the chemistry quarters in second and third quarters so that you have easier cooking quarters, first and fourth, to help balance out your semester grades for those of you who try to do that. So we are going to start talking about the atoms and elements and the periodic table, which is some really cool pizzazz. Because you think about the fact that all of this stuff started like in the 1800s, and the fact that like we as people who live in 2018 sometimes struggle to understand exactly what they're talking about, but these dudes in the 1800s like figured this crap out, and it is freaking amazing. Because you think about that, like they didn't have smartphones, they didn't have computers, they didn't have microscopes to see this stuff, and they were able to discover elements and figure out the periodic table, and it's like mind-blowing to me. I think it is the coolest thing ever, because when you think about it, like seriously, like you guys sit here right now and you look at this and you're like, I would never be able to figure this out. Now think about that before electricity. So not just computers, but just like electricity and all those things. It's kind of cool. Without these dudes, we wouldn't have microwaves, and we wouldn't have microwave popcorn. How whack would that be? Who doesn't like microwave popcorn?
Well, I prefer
Or popcorn. Jared prefers the old school stuff, right? Okay. So we're going to be talking today. We're going to get started with the atomic theory. Now, I'm also going to tell you, as part of this lesson, there are going to be things that are chemistry standards that we are going to gloss over. There's going to be a couple things that I'm going to give you a reading material and a worksheet on it, and that's all we'll cover, because it's not instrumental for us to be building upon. Now, if you want hardcore chemistry for college, then you need to take chemistry with Mr. Miller. Okay, this is a chemistry class that gives you some basic understanding of chemistry, but we don't go into the depth that's really going to have that preparation that you need for advanced chemistry in college. You can handle basic chemistry in college off this with a little bit of extra time spent in college, but just so you're aware of that. This is a good class to take before you take chemistry with Mr. Miller, so it's not all new when you get there. But we're going to start talking about the structure of the atom and the atomic theory. So the first thing that I'm going to have you do is you're going to turn to page 135 in your textbook, and it says the beginning of the atomic theory. You're going to read pages 135 and 136 with your elbow buddy. So Colby, you're going to scoot over. Yeah, elbow buddies, elbow buddies, elbow buddies, elbow buddies, elbow buddies. Actually, no, Colby, you're going to go back with Brody. Okay, so all I'm going to hear for the next 2 minutes is you guys reading. So does that make sense to everyone? David, you're going to pair up with Levi. Okay? What questions do you have? 135, 136, and 137. With Mason. Okay, any other question? Or wait, 2, 4, 6. Oh, we are odd. We'll let you guys, you three, be together right there. Okay. What questions do you have before I turn you loose? What are we reading? Agriculture. You guys just had the opportunity to read about the atomic theory beginnings and the beginnings of your atoms, right? Okay, so in your notebook, you guys can thank Jared for the 3 minutes that have been added on to this class. In your notebook, I want you to open up to a new page. At the very top, this is going to be off a little bit, but we'll survive, right? Well, we probably will. Yeah, we do. We all die sometimes. Right? A new page, yes. The very top of your new page. You're going to label it atomic structure. Or maybe it's actually going to work. Atomic structure. I have. I do. Atomic structure.
Ms. Henderson.
What?
Do you want to proofread atomic real quick?
Atomic structure.
That looks like an I.
Yeah. All right. Ionic, yeah. Ionic. How many minutes do you have between classes, Weston? 3. How many minutes are you guys staying late already in this class? 3. So do you want to add another minute to that? Okay, let's keep it down then. All right. So what is an element from your reading today?
Hydrogen.
Okay, that's an example of an element, but what is an actual element? What's your definition of an element? They're made up of tiny invisible particles called atoms. Okay. Can they be made up of more than one type of atom? No. So elements are matter that is composed of one type of atom. That was fun. So what's an atom then? Smallest, yep. So it's the smallest piece of matter that still has the properties of the element. So an atom is a piece of the element, but it's the smallest one that still maintains all of the properties of that specific element. And Hannah was getting there when she made the comment that an element is, or an atom is made up of what? Right, so atoms are made up of protons, neutrons, and electrons. And protons, the easy way to remember this is protons start with a P, right? So they're positive. So this is a proton has a positive charge. It's a +1 for each one of them. What's a neutron? Neutron is neutral, which is awesome because then you have neutral or no charge. And then you have a electron, which electrons have a negative charge. You think about electricity, you're going to get charge, right? You stick your finger in a light socket. Okay, so where are the protons and neutrons located?
In the nucleus.
Right. So your protons and your neutrons are located in the nucleus. And the nucleus is in the center of the atom. And it consists of protons and neutrons. It consists of protons and neutrons. So if we start to draw our atom, we would have four of these lovely little protons in there. But it's a plus. It's got a plus sign on it. Okay? And then we would furthermore go in there and we would add some neutrons. So we would have some neutrons in there. Okay? There's your neutrons. But what are we missing? Electrons. Where are the electrons located in an atom? On the outside. What's that called? There's tons of words for them, right? We hear the word shells, right? What else did I hear you guys say? Valence shells. Okay, the valence shell is the last shell in the atom that has electrons in it. Okay, so we hear shells, we hear orbits, we hear all those kinds of words. I've heard people say it, but it's actually the electron cloud. So good job, Christopher. Did I not just say good job, Christopher? Electron cloud. So the electron cloud, which is what we call the current, that's what we currently refer to where the electrons are located. We don't always refer to that, or it hasn't always been using that terminology, but that is our current terminology. So this is where electrons travel in specific energy levels so they travel in specific energy levels around a nucleus. Okay? So they're traveling in specific energy levels around the nucleus. Are those energy levels all going the same direction? No. So when we tend to draw out electrons, we draw them in one dimension, and they're really three-dimensional. Three-dimensional atoms are really three-dimensional. So you're going to have one orbital going this way. You have another orbital going this way and around. Then you have another one that's going this way and around, and this way and around. So they're kind of all over the place. I'm not a very good artist, as you can tell. But our electrons are going to be located there. How many electrons will my example on the board have? 5. How do you know that, Brody? Right, because electrons always equal protons. Do neutrons equal protons? No. So we're going to have 2 in our first shell. We're going to have 2 my electrons are, oh yeah, these are neutral. I don't know why I put that there, but these are supposed to be neutral, not negative. Sorry, screwed that up